Hi folks, welcome back to another lesson. So what we're going to look at today is something called algebraic fractions. So algebraic fractions, well, we've got letters and sometimes we've got numbers. So what we're going to look at is the interaction between the fractions. Like it's in here, we're going to look at basic operations. Operations just means doing things, like, and for us, between two fractions, or even more later on. So we are going to look at the basic operations of add, subtract, multiply, and divide. That's for four basic operations. And like I said, we are going to be looking at these operations and interactions with fractions. So, for example, a over b plus c over d, x over 2 take away x over 3, 4a over c times 5a over d. Oh, one more. 2q over p divided by 5q over 3t. If this is the first time that you've seen something like this, don't be surprised at the answers. Anyway, here we go. AD plus BC all over BD, x over 6, 20a squared over c times d, and finally 6t over 5p. So, like it says there, it's not always obvious how we get these answers or how we arrive at them. But that's why we're here. We're going to learn about it. So, what we're going to do is, you don't like letters. In fact, we get emails these days, we don't even get letters. So we're going to look at some fractions with numbers in them, numerical fractions. So we'll get some here, like 1 over 3 plus 1 over 3, 5 over 7 take away 2 over 7, 9 over 10 take away 3 over 10, 4 over 11 plus 2 over 11. So, go on, who's going to go for the top one? 1/3 plus 1/3, what do you think? What do you think? 2/3? I think so. 5 over 7 take away 2 over 7. 3 over 7. Do you get that? Right. Next one. 9 over 10 take away 3 over 10. Do you get that? 6 over 10. And some of you are shouting out, no, I got a different answer. I got a different answer. We don't want decimals. Don't want 0.6. Did you get this? 3 over 5. Yep, that's fine. And previously we spoke about how to simplify things. That's okay. So we're just going to go for 3 over 5 here for that answer. And finally, 4 over 11 plus 2 over 11. Guess what? 6 over 11. There you go. That was quite nice. And the thing was, with all of these fractions, I don't know if you noticed that the bottom numbers in each line, each specific line, were the same. So in the first line, we had 3 in the bottom, second line we had 7 in the bottom, third line we had 10 in the bottom, and the fourth line we had 11 in the bottom. So apart from line 3, where we could actually simplify that, everything stayed the same. Right. And that's the bottom numbers, they're called denominators. So what we had there was a common denominator. So we just had to add or subtract between the top numbers, and that was fine, unless we could simplify, that we did in example 3. But what if you get something like this, where the bottom numbers are different, like a half and a third? Oh, and some of you are going to say, well, that's 2 over 5, or whatever it is. Some of you who paid attention in school, well, you might get the right answer. But we can think about this in kind of roundabout ways. So let's have a think about it. And even that one, 2 over 7 plus 3 over 13. What could that possibly be? But we'll deal with both of them. So we'll probably take a wee bit of time dealing with the first one, a half plus a third. So here, we can think about this kind of visually. So a half of something. So I've got two circles here, so I'm going to half the first one, and the second one, I'm going to split it into three parts. So on the left, it looks like I've got a half, and on the right, it looks like I've got a third. Right, I know that I always talk about pizzas, but that's fine. Right, it's not a brilliant drawing, but anyway, I don't get paid for doing that. Okay, so let's go for it. So if I just stick those two together into maybe the one circle, so I'm interested in the red shaded parts. So if I put them together, I get that. But I'm not really pleased with that. So what could that possibly be? Well, if I subdivide all the circles even further with my pizza scenario, I can cut them into 6 parts each. And it looks on the left hand side, the half, it looks like I get 3 sixes. And on the right hand side, the third, it looks like I've got 2 sixes. And the extreme right hand side, after the equals, it looks like I've got 5 bits out of 6. So a half plus a third is indeed 5 6. But we're not going to sit about drawing pizzas all day. Okay, so what we need here is a wee rule. And the rule applies both to add and subtraction between two fractions. We're just going to stick with 2 at the moment. Okay. So I've got A over B plus C over D. Oh, no numbers. Dangerous. Right. So how we're going to go forward here. If the bottom numbers are different, letters in this case, so what we're going to do with those two, we're going to combine them into the one fraction. So we take the two bottom parts, denominators, and we're going to multiply them together. So that's what the little arrow, double-headed arrow is indicating. So that's saying B times D here. So that's what I'm going to do. So B times D, and like it's saying, multiply those together. Then what we're going to do is go take the bottom right-hand part of the fraction up to the top left of the other fraction and multiply those together. So that's A times D. So that's what, so just take that, like it's saying there, take the bottom right up to the top left and multiply. So that'll be A times D. Finally for us here, take the bottom left up to the top right, so that's B times C. And so those blue arrows are indicating that we're taking the bottoms up diagonally opposite. Okay. And that's what it's just saying to you there, just to clarify it. Right. So what we're going to do now is actually bring things together. So we get B times D, put that in the bottom. I've kept that plus there. Now got the one fraction, so I'm now going to bring up my D times A, or A times D, doesn't matter the order. I used to do it in alphabetical order, but that's unimportant. But I've got that result there. And finally for this, the B comes up to multiply the C. So BC or CB, whatever you fancy. That's my answer. We don't have any numbers here, but that is, well, one method for doing it. And this method, oh, I'm making a promise here, it's always going to work for us. So let's go for it. So we'll go back to the half plus a third and see how this actually works for us. So the two bottom parts together, 2 times 3. So I'm going to create a fraction. If you get a plus or a minus, always put that in the top in the centre. We've done that. So it's a 2 times a 3. They're down the bottom. Next, I'm going to take my bottom right up to my top left. So it's going to be 3 times 1 or 1 times 3, whatever. Done that. Then I'm going to take the 2 up to multiply the 1, as indicated there. So we've done that there. So now you can just do your 3 times 1, your 2 times 1, and your 2 times 3. I'm sure we can all manage that. And the top line is just indicating the order that we carried out those multiplications. So 3 1s, 2 1s, 2 3s. There we go. So it's all over 6 here. And on the top, we get 3 add 2, so why not just do that? 3 add 2, and is indeed 5 over 6. And if you rewind back to the pizza scenario, you'll see we did indeed get 5 over 6. This one here, I'm going to do it a wee bit quicker. So I've just put in my little arrows here. The bottom one in red, if you've not got a black and white telly. So I'll get 7 times 13 in the bottom. Then I'm going to bring the 13 up to multiply the 2, and the 7 up to multiply the 3 as indicated. Okay, so now I'm just going to go through it. 13 times 2, 26, 7 times 3, 21, and 7 times 13, what's that, 91, I think? Let's see. Oh yeah, well done, Tommy boy. Right, so we've got our bottom sorted out. On the top, you're either adding or subtracting. We're adding in this occasion, so 26 add 21, what do you get? 47 over 91, and there you go. I know your calculator can do this because we've got numbers, but the thing is, you're going to have letters later on. So we need it. So it's a rule, the technique, whatever they want to call it. It's important for 47 over 91, and that's not going to simplify here. We're fine with that, right? Okay, let's move swiftly on. And I'm saying swiftly here, but you can always pause this because it's a little video. You can always pause it, rewind, just like you're on YouTube. In fact, this might be on YouTube. I'm not sure. I've not decided yet. Anyway, let's go. Oh, he's put in letters now. Oh, he's trying to confuse us. But it doesn't matter. As long as we apply the same rules, so bottoms together, the 4 goes up to multiply the x, and the 3 goes up to multiply the other x on the right hand side. So I'll put in my little arrows to indicate what's getting multiplied here. Okay, so on the bottom, the 3 times 4 is 12. Then the 4 goes up to multiply the x, and the 3 goes up to multiply the other x as indicated with the arrows. So 4 times x, 4x, 3 times x, 3x. There you go. And can we add 4x and 3x? I think it looks like we've got a total of 7, or 7x over 12. There you go. Not bad. Okay. Here, kind of similar. We're subtracting here. That doesn't matter. The rule still applies. So let's put in my little arrows to indicate the order that we're going to multiply things. Let's get the bottom sorted out. 2 times 3, 6. And please notice I put in the subtraction symbol, the minus. It's going to be between 2 entries. So take up the 3 to multiply the x and the 2 up to multiply the other x. Okay, so 3 times x, 3x, 2 times x, 2x. 3x take away 2x. Can we do that? I think we can. Just going to leave this one lot of x, or a single x. Done. All over 6. Not bad. And something being divided by 6, that's saying it's a sixth of it. So in some textbooks, they might have either of these. Okay? Because we're dealing with fractions, I said this earlier, don't decimalise things. Just see how you go on. Right? Another one. This time, both are over x. So if you were to follow the rules that I'd shown you there, you would carry out your little operations there. So x times x squared, 2 times x, 2x, 3 times x, 3x, or x times 3. You'll end up with that. And we might have spoken about cancellation in a previous lesson, or not. So 2 take away 3 is negative 1. I'll get negative 1x, or just negative x over x squared. But the thing is, we can cancel here. We can cancel a single x from top and bottom. So negative x divided by x is just negative 1, and x squared divided by x is just x. So that there. Usually, if you got a negative sitting top or bottom in isolation, you'd usually draw that out the front and level with the fraction bar, like that there. But don't get too uptight about that. I'm sure it should be okay. Right, but practice makes perfect. Okay, moving on. Some of you might have spotted, that the bottom part was the same here. So I'm just going through this question again. If the bottom part is the same in a fraction, just like our first four numerical fractions, what we did is we kept the bottom part the same, okay, and then we just had the interaction between the top parts, which is 2 take away 3. 2 take away 3 is -1. Yep, and that's what I've got. And yet again, I'm drawing that negative out the front. So here, the point I'm trying to get at here, always look at the bottom part, the denominator. If it's the same, just carry out the operation add or subtract on the top. Then you won't have to go through all that malarkey about the multiplying out and cancelling if you need to. I'm happy with that. Oh, quiz. What's a quiz? You're probably fed up with all the quizzes on Zoom. Quiz. What's a quiz? Oh, we're leaving behind add and subtract. What's a half times a half? Oh, what are you going to put there? Is it going to be 2 over 4? Is it going to be 1? Whatever. Why not have a guess? We're all in this together. But that's a better question. See, multiply. When we're in maths, usually we can consider multiply as being something of something. Okay, so that's what multiply actually means. So half times half is half of a half. That's what I've got there. So half of a half. Oh, let's get back to the kind of pizza scenario here. So I've halved it, my little circle here, pizza, whatever you want to call it. But then I'm going to half it again, because that's what I want, a half of a half. And pictorially, it looks like I've got a quarter on my circle there, my pizza. Yep, indeed, it is a quarter. What about this one? A half times a third? Half times a third. Well, let's think. So I put in thirds initially, but in the bottom third, I've actually halved that. What could that possibly be? Well, if I put in another few lines here, it looks like I've cut it into 6 parts here. So it looks like a half times a third, or a half of a third. It's actually a 6. That looks like a 6 to me. So the thing is, I just said, we're not going to be drawing circles, pieces, whatever, all day. So we need rules for multiplying fractions here. So here, I'm putting in letters here, because that's what we'll usually have. So I've got A over B times C over D. So the rules we have here, it's a lot easier than adding and subtracting. It's simply just multiply the tops together, multiply the bottoms together. That's what the little arrows are indicating here. So it'll be A times C and B times D. So if the letters are different, just stick them together. Okay? AC over BD. We don't have anything similar top and bottom, so that's your final answer. Like it says, what about this one? X over 2 times x over 3. We're multiplying, so why don't we just use that rule that we've just learned? Multiply the tops together, multiply the bottoms together. That's what the arrows are indicating here. So x times x, you've learned something times something is the something squared, so it'll be x squared and 2 times 3 is 6. That looks good to me. Ooh, 9x over 5 times 20 over 3x. Why don't we just stick with the rule here? Okay, instead of doing everything by 15 different methods. So 9x times 20 and 5 times 3x. It's one of the numbers that can interact here. We don't have any, so 20 times 9 or 9 times 20, 180, stick the x in it. 5 times 3 is 15, stick the x in it. Top and bottom, we get something in common, which is x, and we've got this process known as cancellation. So we can cancel an x top and bottom. And 180 divided by 15, is it possible that 15 goes into 180? What do you think? 12, is it 12 times? It is indeed. There you go. And x is gone because it cancels out on both top and bottom. X over x, something divided by itself is 1, and 1 times 12 is just 12. Oh, I'm nearly home and dry here. Division. Right, we've done add, subtract, multiply. We're moving on to division. So we're on a home run now. Half divided by an eighth. Right. What do they mean by this? Like it says, this is really the question. When you're dividing by something, they're saying, how many eighths can we get out of a half? That's what they're saying there. Just like 10 divided by 2 would mean how many 2's can we get out of 10, and hopefully you know that's 5. So I'm going to go back to the pictures here. I've cut this into 8 parts. So how many of these slices can I get out of half of this circle? So just half it. That's 1/2. And each of those little segments I've got there are sectors. You'll learn about that later. How many of those have we got? 1, 2, 3, 4. So a half divided by an eighth actually gives me 4. Right, and you're thinking, oh, how do I get 4? Well, we're going to see. Here we've got the rule on how to divide. Again, I've got rid of the numbers. A over B divided by C over D. The thing is, we don't like divide, but its partner in crime, its opposite is multiply. So why don't we keep the first fraction the same, and we'll change divide into multiply. And I can't just do that out of nowhere. So just like I said there, divide and multiply are opposites. Because I've changed one for the other, what I have to do to compensate, see that second fraction, the C of D, to compensate that, because multiply is the opposite, which is the inverse, or invert. So I'm going to invert the second fraction, which means turn on its head. So the C over D, it becomes D over C. See how I'm inverting it there? So that's a wee trick there. And the reason we've done that is because the multiplication rule between fractions is easy. Okay, so there you go. I'm just emphasising invert divide to multiply, and invert or flip the second fraction. We've done that. Great. So now we can just multiply the top and bottom together. Right, so it'll be A times C, and the bottom B times C. There you go. And because the letters are different, we'll just stick them together. And that's it. Are we okay there? Right. So that's our fourth rule. So here we go. This is without the circles, the pizzas, half divided by an eighth. So like we said there, keep the first fraction the same, change divide into multiply, and turn the second fraction on its head. Okay? The top parts I've got 1 and 8, multiply together, so it's 1 times 8. And on the bottom I've got 2 times 1, which is 8 over 2. And can you divide 8 divided by 2? That's what fractions mean. How many of the bottom parts go into the top? 8 divided by 2, what do you think? 4. Yay! Brilliant. I'm pleased with myself. Right. So here, we're putting in the letters again, just to see if it actually works. And the thing is, your calculator can't do this. Oh, well, unless no, I'm not going to suggest anything to you. I'll just complicate it. So x over 7, we'll keep that the same. We're going to change that divide into multiply, and we're going to turn the second fraction on its head. So x over 6 becomes 6 over x. Done that. So I'm just going to multiply the top bits together. So it's x times 6, or 6 times x, and the bottom we're going to have 7 times x. Usually, x times 6, you could write it as x6, but usually It's good mathematical grammar, and that's me, it's just saying it. It's no some professor, it's no Wikipedia, it's no Google, it's me. I'm the person in front of you. We're on the end of the line. So I'll get 6 times x over 7 times x, so 6x over 7x, and you might notice, like in one of our previous examples, if we got something similar top and bottom with the same power, x over x, they're the same, so we can cancel them out, because x divided by x is 1, and that'll just merely leave me with 6 over 7 times 1, which is 6 over 7. There you go. Whew, this is hard going here. Oh, I didn't want to show you that, but see for any of you who are paying attention, and if we've done an indices lesson, you can try that, especially question 2. But in this class, because this lesson will be showed to many classes, and sometimes we do things in different orders, so don't get all uptight if you've not tackled question 1 yet. That's to do with a topic called indices. But I think for this lesson, you could um, you could attempt question 2, but do you notice there? I've got three fractions in question 2. So I think we could try that. Okay. And if you're feeling good, why don't you try that one? So we've dealt with fractions, but this time we get 3 fractions, 1 over a plus 1 over b plus 1 over c. And if you've done a little bit of physics, you might recognise something like this. Okay, especially to do with things called resistors. And that doesn't mean that you resist me, or whatever your lecturer is. Right, so I think I'm going to finish it here, folks. Are we all okay with that? And like I said, you can always go back um, and watch it again. That's what I always do. And I keep saying things like, you don't just listen to a song once, you listen to it again and again. Same thing. It's like maybe reading a book again and again. So why don't you go back and look at your notes again and again, and your lectures, little videos, or whatever they send you. So what I'm going to end this here, folks, okay? So thanks for listening, and any questions, but not too many, and don't be emailing in the early hours of the morning, because I'll be off duty. Right, thanks very much, folks. I'll see you later. Bye.